So in this section, we're going to look at solving systems algebraically through the substitution method. The first step in our process is going to be to isolate one of the four variables that we see in the two equations. Now, when we look at these two equations, we've got two candidates for isolation. That's the x and that's the y in the second equation. The reason why we'd rather isolate these two variables is because they don't have coefficients. So all we simply have to do to isolate y is to subtract x from both sides. Cancel out the x's, bring your y down, y equals negative x minus 12. Now we know what y equals. So we're going to circle this quantity right here, the negative x minus 12. That's what we're going to substitute into the other equation. So we're going to take that first equation that we haven't touched yet, and we're going to bring that down. And we're going to put in 2x minus 3, and we're going to substitute negative x minus 12 in for the y. And that's going to be equal to 6. So it's very important that when you do this, you put that quantity into parentheses, because we must distribute this negative 3 through to both the negative x and the negative 12. So what you'll do is go ahead and bring this 2x down, distribute the negative 3 to get positive 3x and positive 36. We're going to set that equal to 6. Next step, combine like terms. So you end up with 5x plus 36 equals 6. We still have to isolate the x, so let's subtract the 36 from both sides. Cancel out the 36's. This is going to leave you with 5x equals negative 30. Again, I continue isolating the x, divide by 5, and that's going to leave you with x equals negative 6. Now the next step in the process is to take the known variable, that x equals negative 6, and we're going to put that back into the original equation that we selected. So that was x plus y equals negative 12. So that's going to become negative 6 plus y equals negative 12. Now we isolate the y. In order to isolate y, we have to add 6 to both sides. When we add these 6's, they cancel out. We're left with y equals negative 6. Now that we've got our solution, we know that the solution is negative 6, negative 6. In order to check this, what we're going to do is we're going to take the x value and the y value and plug it in to this equation now. So that's going to be 2 times negative 6 minus 3 times negative 6 equals 6. Now we're simply going to work this out. 2 times negative 6 is negative 12. Negative 3 times negative 6 is positive 18, and that's going to be set equal to 6. Negative 12 plus 18 is 6. 6 equals 6, so we know that our solution is correct. In this section, we're going to solve systems algebraically using the elimination method. The first step in order to solve this with the elimination method is to take a look at our variables. We have a 3x and a 2x. We also have a 4y and a 3y. In order to eliminate, we need to make the coefficients of one of the variables opposites. So in order to do that, we take a look at the 3x and the 2x. We're going to need the least common multiple of 3 and 2. Least common multiple of 3 and 2 is 6. If we take a look at the 4y and the 3y, the least common multiple of 4 and 3 is 12. So the easier one to eliminate is going to be the x variable. So what we'll do in order to get to 6 is we're going to multiply the top equation by 2. We're going to multiply the bottom equation by 3. But you have to remember at this point that in order to eliminate the variable, your coefficients have to be opposites. If we multiply 2 times 3, we're going to get 6. If we multiply 3 times 2, we're also going to get 6. What we need on the bottom is a negative 6. So we're going to multiply the bottom equation through by a negative 3. We're going to go ahead and rewrite these with the products. So 2 times 3x is 6x. 2 times 4y is positive 8y. 2 times 10 is 20. Negative 3 times 2x is negative 6x. Negative 3 times 3y is negative 9y, and negative 3 times 7 is negative 21. At this point, you can see that we've got opposite coefficients for our x variables. We have a 6x and we have a negative 6x. We can then go ahead and eliminate that variable. So the 6x and the negative 6x cancel out, and we're left with 8y minus 9y, which is negative y. That's going to be equal to 20 minus 21, which is negative 1. You now have to isolate your y variable. To isolate y, since it's being multiplied against by a negative 1, we can divide it by a negative 1. That's going to leave us with y equals 1. We now have our y variable. That's a known variable. So we're going to take that known variable and we're going to plug it into one of the original equations. So let's go ahead and take the first original equation, which was 3x plus 4y. But instead of plugging in y, we're going to substitute 1 in. And we're going to set it equal to 10. Work this out. 3x plus 4 equals 10. At this point, you're going to isolate the x variable. So subtract 4, cancel out the 4's, you're left with 3x equals 6. Now continue isolating the x, divide by 3. That's going to give you x equals 2. So the solution to this problem is 2, 1. Now before we stop, we want to go ahead and go back and check this. Make sure that we've done this correctly. Since we used the first equation to find the x variable, we have to go back and we have to use the second equation to check our work. So what we're going to do is we're going to plug in, instead of x, we're going to plug in 2. Instead of y, we're going to plug in 1. So 2 times 2 plus 3 times 1 equals 7. So 2 times 2 is 4, plus 3 equals 7, and we can see that 7 does equal 7, so we know that our answer is correct.